Hey there, legends. Here's a quick guide to the solutions to the practice exam. Hopefully will give you some inspiration for what to study and what to put in your sheet of notes, etc. Right, speaking of your sheet of notes, you're allowed to bring one into the exam. It's one piece of A4 paper, double-sided, but crucially, you can't have it folded and you can't have anything stuck to it either, including whiteo. Sounds pedantic, but the reason why is that if you had whiteo or something that could unfold on your paper, it would mean that you could, scratch it off or reveal something else that would give you more than one double-sided page's worth of space to work with. It sounds a bit pedantic, but that's just one of the rules. So make sure that you stick to that. The other thing is that for your calculator, it's really important that you bring your own for this assessment. One of the reasons for this is if you rely on borrowing a calculator and then find that you don't know how to do something on the calculator, we can't tell you how to do it in the exam. You're pretty much on your own for the whole exam. Whereas if it's a calculator that you know and you're able to use, one that you're used to, it's obviously going to help you out quite a lot. Okay, I'm going to go through each of the questions with some suggested notes that you might like to take as well. For question 1, the key word here is that we're evaluating the expressions. That word evaluate means that we need to write a value as an answer. It's kind of like we've got to evaluate what it is. So some of these you'll be able to do in your head. So for example, 0.3 plus 0.6, you could probably just do that equals 0.9 in your head really quickly. But questions like this one, 1.8 times 0.3, rather than working those out using whatever algorithm you like, it's a lot easier to just put it in your calculator, and it's going to save you time on the exam as well. Hence this note here, you're allowed to use a calculator on the exam, so use it for this question. So it's particularly important for the multiplication. The division would be quite hard to do using an algorithm or pen and paper as well. The ones that I'll just point out for you to double check your practice test answers for, be mindful that for questions like this, 17.34 over 5.1 means divide. We're dividing 17.34 by 5.1, so make sure you know that. Also, make sure you know how to use the square root button on your calculator as well. That's obviously really important. And I think that's pretty much it. Oh, and also this one here, 6.2 to the power 3. Just remember that 6.2 times 6.2 times 6.2. 6.2 multiplied by itself 3 times. Or you can use the cube button on your calculator. So 6.3 cubed, and then that will give you your answer as well. Again, that's why it's important that you're using your own calculator, because you can figure out how to cube things on your calculator and do so pretty much. Okay, question 2. Going to identify whether the following decimals are repeating or terminating. So repeating decimals rather have digits that repeat forever, and I've summarized that here. Basically, if you put 1 over 3 into your calculator, you get 0.3, and then the 3 repeats forever, keeps going. And the way that we rewrite that is to say 0.3, we put a little dot above the 3, and that tells you that the 3 repeats. Similarly, for 2 over 11 is my other example. 2 over 11, if you were to place that in your calculator, gives you 0.181818. It's the 1 and the 8 that repeats, which would be 0.18, and we put a little bar above the top. It's got a special name that I can't remember in this exact moment, so I hope you'll forgive me for that. But that tells you that it's the 1-8 combination that repeats forever. Terminating decimals, on the other hand, they don't repeat forever. They terminate, they stop. So 3 over 4 gives you 0.75. Yeah, there's decimals there, but the decimals don't repeat. 0.75, and it stops. For 387 divided by 1,000, similarly 0.387, but it stops. So for that reason, 0.9843 is terminating because it stops. 2 over 5, you can check on your calculator if you want to be super sure. 2 divided by 5 is 0.4, which again, it terminates, so that's it. This next one, 0.5481. You've got that bar above the 8-1, which tells you the 8-1 repeats forever, so that one is repeating. And for this one, 49 and 4/9 as a percentage, just do 4 divided by 9 on your calculator for this one, because that's going to give you 0.4 recurring, which tells you that 4/9 is a repeating decimal, which means that 44 and 4/9% has to be repeating. Cool. For rounding, we want to round to the nearest number to however many decimal places. And some tips for your notes, if this is something that's hard for you, it could be to write in these steps up here. First step is to decide which is the last digit you want to keep. So I'm going to use this as our example, rounding to 6 decimal places. So the last digit we want to keep is the 6th one. So I'm going to count along, 1, 2, 3, 4, 5, 6. So that digit there, through what is currently a 3, is going to be the last digit that I keep. So my answer is going to be 1.41421 something. So that's part 1. Then I want to leave the digit the same if the next digit is between 0 and 4. But if we have a digit after it that's between 5 and 9, we increase it by 1. So now I'm going to look at this digit that's next to the 3. It's 5, which is between 5 and 9, which means I'm going to increase that 3 by 1 and put down a 4 instead. So the reason for that is that this number here rounded to 6 decimal places, it's slightly closer to 1.414214 than what it is to 1.414213, which is why we rounded it up. So there's a little bit more practice on that for you to check your answers against. Rounding to the nearest 10,000 million works in the same way, there's just no decimal places. So to the nearest 10, that's the digit I'm rounding to. So to 460, I'll just pop that here. If it's the nearest 1,000, I want to look at the place value place for 1,000, which would be rounding to that number there. Nearest 1 million would be this one there. Nearest 10 million is this one here. So yeah, it's the same as rounding with decimals, but you're just rounding to a particular place value with these ones. So it works in a similar sort of way. Okay, evaluate, there's that word again. We need a value in our answer. So you could use your calculator for this one. This first one here, 5 to the power 4, you just think that means 5 times 5 times 5 times 5, which is 625. 1 to the power 0, anything to the power 0 is 1, so our answer is 1 for this one. Here we've got to be a little bit careful, because it's negative 6 to the power 3, which is negative 6 times negative 6 times negative 6. So what we think there is, well, a negative times a negative is going to be a positive, but then times a negative again is going to give us a negative. So it's a good guide that we need a negative as our answer. So yeah, negative 216 is what we want for this one. Okay, for these simplify questions, we want to simplify using index laws. So here we've got 3 to the power 7 times 3 to the power 10. So that means 3 to the power 7 is 3 times 3 times 3 times 3, 7 times, right? 3 to the power 10 is 3 times itself another 10 times. So that means that in total we've got 3 multiplied by itself 17 times. You've got the first 7 and another 10. We get that 17 by adding the 7 and the 10 together. Similarly, for the next one, 8 to the power 21 divided by 8 to the power 6. When we divide the bases, we simplify the powers by subtracting, and which is where this 15 comes from. We've got 21 take away 6. Now, just remembering, I explained this really slowly in the test 1, I think, revision video. So in the description, I'll put a link to that. If you want a long explanation of this one, or something that goes into more detail, then you can just check that out. Okay, these are from the most recent test. I've got as an example of something that could go into your notes, the factors of 12 and the multiples of 12, just to give you a list, so to help remind you on the day. So the factors of 12 are the numbers that fit into 12. So 1, 2, 3, 4, 6, and 12, they all fit into 12. The multiples of 12 is kind of like the 12 times table. So 12, 24, 36, 48, and so on. So here where you've got list the factors of 36, you want all the numbers that fit into 36. The way that you can do that is using factor pairs as well, by the way. You know that 1 and 36 are going to fit in because 1 times 36 is 36. Now I'll check for 2. Yeah, 2 fits in. 2 fits in there 18 times, so 2 and 18 are going to be factors. 3 fits in there 12 times. 4 fits in there 6 times, and now we've got to the middle. By the way, I've realized that my pen is shaking the camera around. I hope that's not too distracting. Yes, so that's one way you can find the factors of a number. But when you see factors, we're looking for all the numbers that fit into whatever number it is. Similarly, first 6 multiples of 36, you're just going through the 36 times table, and you could use your calculator for that if you like. So 36, 72, 108, 144, and so on. Okay, the highest common factor is the highest factor that's common to both numbers. So in the case of 36 and 48, we're looking for the biggest factor that fits into both, which would be 12 for that one. The lowest common multiple for those ones is the smallest multiple that's common to both, which for this one is going to be 144. Because 36 has got these factors, 48 has got these factors, but 144 is the smallest one that is common to both of them. Okay, I won't go through the next one because that basically just repeats the question again, but make sure you check your answers against that to make sure you're on the right track. Okay, for question 6, we're doing factor trees. So this is where we break a number down into its prime factors. 280 is the first one that we have to break up into its prime factors. Easiest way to do this is just to start by dividing by a prime number, or really any number that we know fits into this one. So for example, 280 we can divide by 2. That'll fit in there 140 times, because 2 times 140 is 280. I've broken this down a little bit further here. So 140 we could do 14 times 10. So I've got 2 separate branches breaking off there. 14 is the same as 2 times 7. 10 we can break up into 2 times 5. And we know when to stop. We know that we need to stop when we hit a limit of prime numbers like that, because we can't break down 2, 7, 2, and 5 anymore. So as soon as we hit our prime numbers, we stop. Cool. Answers there for 240 if you want to check that. Now, to use your factor trees to find the LCM and HCF, what you do for these ones, you can give yourself a little Venn diagram. Any factors that are common to both of them, so both of them have 2, 2, 2, and 5 as prime factors, so they go in the middle. 280's got an extra 7, we plonk that here. 240's got an extra 2 and 3, they go just there. But we can find the HCF by multiplying all the common factors together. We can find the LCM by multiplying all of the prime factors together. That's at the harder end of what's on the test, so if you're aspiring to get close to 100%, that's a technique that you could maybe get onto your sheet of notes, get a couple of examples drawn in there. Right, question 7, these are all lowest common multiple questions. So the first one, we've got 2 water clocks running at the same time. 2 water clocks, one drips every 25 seconds, the other drips every 35 seconds. If we start counting time when they drip together, bloop, like that, we're looking for the next time that they drip together. So after how many seconds they go again. Easiest way to do that is to list the multiples of each number. So clock A is going to drip after 25 seconds, so then 50, 75, 100, 125, and so on. So you make a list of those multiples. Do the same for B. That's going to be at 35, 70, 105. I'm just adding 35 each time here. You keep doing that until you get a multiple that's common to both, which for this one is after 175 seconds. So this would be worth 3 marks. 2 marks for using a method to find the lowest common multiple, and then a 3rd one for stating what it actually is. So you can either make a big list like that, or you can use this Venn diagram thingy and the factor trees above. Whatever your preference is, doesn't matter. Okay, more answers for you to check there. Question 8 is all about congruency. And congruent shapes are the exact same shape and size. So we're looking for pairs of congruent shapes for this one. So you're looking for ones that are the same size and shape. So these two match up, these match up, these match up, and these match up as well. So I think 1 mark for each pair that you identify there. This one is all about congruent tests for triangles. So you're essentially trying to say which test will we use to prove that these are congruent. We just need to identify the reason that would be used. For this one, we've got a pair of sides here, pair of sides here, pair of sides here that are all the same. So side, side, side for that one. The second one, you've got two angles and another side length as equal pairs. So angle, angle, side for this one. The next one, you've got a right angle, hypotenuse, and another equivalent side that are the same. So you want right angle, hypotenuse, side for that one. Then the next one, you've got two sides and the included angle matching up. So side, angle, side for this one. The next question is a little bit more complicated because you're going to write an actual proof for it, where essentially what you've got to do is match the sides together that are the same. So for this one, angle B in our first triangle, so angle B just here, is equal to angle P in that triangle. So that's where this answer, angle P, comes from. By the way, that little symbol there just means angle, and the little P means the angle at P. Then GB, so side GB is equal to side XP, which would be this one here. So that, when you write down BG or GB for that one, it's just the side length that's made between those 2 points. So to interpret that. And then you pretty much fill it through and then write down the reason for congruency there, which you could maybe get from your sheet of notes as well. So maybe these 4 congruence tests, probably a good idea to have in your notes to remind you. And then this second question is definitely at the extension end and one of the hardest questions on there. So you're writing your own proof for these ones. So it's taking the scaffolded steps from the previous question and writing it one step after the other. This is probably something that is going to be at the extension end. So if you're doing this question, it probably means that we've done some of these questions together at some point. But if you still want to give it a go, it might be a good idea for it to be in your notes as well. Okay, for these questions, we're finding the angle of the missing polygon. I won't go into this too much because I'm conscious of finishing this before the bell goes. But for this one, essentially, if you've got a 4-sided shape, the angles have to add up to 360. So 90 plus 90 plus 75 plus something, it's got to equal 360. So you figure out what the something is. Similar thing for this one. That missing angle has to be whatever makes it up to 360. So that's how you find your answer there. For these ones here, you've got an angle and an angle that's double the size. So that one needs a little bit of algebra. That's a bit of a problem-solving question, so that's more of an extension sort of thing. This one, you've got to gradually solve the puzzle, I guess you could say. That's missing a digit here, by the way. That's going to be 50 or 51. So you're missing a couple of things there. That's okay, though. But yeah, 309 plus 51 would make 360. These add to 180. This would add up to 360 in the whole shape, and then that adds up to 180 on the line as well. So yeah, a few different parts to that question. Okay, for Pythagoras, should I pause it? Carry on? Nah, I can do it in a minute and a half. That'll be okay. Right, Pythagoras is one of the most recent topics that we've done, so hopefully it's fresh in your mind. But this is where for every right angled triangle ever, if we square the 2 shorter sides and add them together, we always get the length of the third side squared. So we can use that information to solve problems. For this question here, we're finding the longest side. So we can square those 2 shorter sides and add them together, which gives us 1,369 in this case. But that's the length of the longest side squared. So to find the actual length of the side, we've got to find the square root of 1,369, which ends up being 37. The other version of this is when we're finding a shorter side. We follow similar steps for this one, but we're going to take the longest side squared and take away the length of the other shorter side squared. Then we follow very similar steps after that point. Okay, really quickly for these next ones. Terms are kind of like the building blocks. They're like individual units in an expression. An expression is a combination of 2 terms added or subtracted together, or multiplied for that matter. And then an equation It's the whole thing, and the giveaway for an equation is the equal sign. So say here we've got an equal sign, got to be an equation. This is just one thing on its own, that's got to be a term. The next one has got two terms added together, has to be an expression, so on from that. I think that should be all right for most of you. For the next question, for substitution, we want to swap the variables for the numbers that are given and then evaluate. So what we want to do, it says b plus c. So we want to take the value for b that's given in the question and add it onto the value that's given for c. So for this one, we're essentially taking the variable and swapping the variable for the number that's given. So that's what variables do, right? They can take on the value of heaps of different numbers. Okay, I reckon we can rip through the last ones nice and quick. For these simplifier ones, we want to collect like terms only. So 12f means 12 times f. If we take away 8 lots of f, we're left over with 4. I reckon, Miss B, I can do the last 2 questions in 1 minute if that works for you. Hey, that could be a positive. Okay, for these expanding questions, we've done these pretty recently as well. But the way, when we see that word expand, it means that we want to remove the bracket. And the way that we do that is take whatever term we have out the front of the bracket and multiply it by everything that's on the inside. So in this case, we had 2 times x, which gives us 2x, and then 2 times 4 gives us 8. What I might do for these last 2 questions, actually, because I'm cognizant of rushing through a tricky topic. This is in one of my previous revision videos, so what I'll do is leave a link to that in the description if you want to spend a lot more time on either brackets or on factorising, which is the last thing that's on the test. But similarly, if you look at the revision that's on OneNote/Compass, there's some steps that you might wish to use to help you. So factorising, putting it back into brackets, there's some steps there that might help you in your notes. Similarly for expanding, removing brackets is the aim of the game. Good luck with the exam. Email me if you've got any questions. Nice one.